Okay, welcome to lesson 3. This is actually the fourth notebook because there's an assignment notebook that you can go that reviews the first two lessons that we covered. But this is the fourth notebook in the GitHub repo. Okay, so we're going to get started with data analysis. And we're going to introduce two very important libraries, part of the scientific Python stack. The first one is NumPy. They're actually quite related. One NumPy or Pandas built on top of NumPy, but the first one is NumPy, and what they provide is an array class, um, that a new data structure that allows you to do some pretty cool things. First, it's very similar to a list in Python, um, as you can see, but the constraints are that it should only have the same data type. So these are all integers, or you could have all floats, um, or you definitely don't want to put you don't often put strings in NumPy arrays, but you could, I think. But it's mostly for numerical programming, so uh, it's usually floats or integers in here in a NumPy array. Uh, but the cool thing that you can do is, first, the computations are very quick because it's actually written in C or C++. Uh, and so they're going to be a lot quicker than you would do with a list. Um, but you could also do things like this, which is they're called broadcasting, which is I'm multiplying this entire array by this scalar, um, and you'll see that it broadcasts that multiplication across all elements of the array. And that's very useful. You can't really do that in list as easily. It's possible to do with some, with a for loop or with like a map function, uh, which we didn't really cover. Because if you just run it like here, I'm just extracting this list, you'll get a type error. Can't multiply sequence by non-integer of type float, right? And so, but with with a NumPy array, you can't do that, and it still works kind of like list. You can index into them similar like a list for the first cash flow, the last cash flow, in between, the fifth and the eighth, and so this is a foundational data structure. Um, and you can still do a lot. And the NumPy library itself has a lot of other features. So this is just one of the more important ones, and we'll get more into some of like the financial functions that NumPy provides later on. But to build on top of NumPy, we introduced pandas, and so it's one of the most popular libraries for data analysis in Python. And there's a lot of similarities between the data frame and an Excel sheet, which we'll look at a little bit. But it's not, kind of go into just the pros and cons of each. But the focus here is the two new data structures that Pandas provides. One being the series, which is more like a column of data or a row, and then the other one being a data frame, which is that spreadsheet matrix-like data structure. So let's take a look at the series first. So here's how we create a new series. Very similar to creating a new NumPy array. And it's actually so similar. Now the one difference is, the series does have an index, right? So we have our values, but it shows us this index here, and it starts at 0 like a list. The data type is N64, which is similar to an integer, but it's like specific. I believe it's a specific pandas type. And so if you do the dot values on a series, you'll actually get returned a NumPy array. That's how similar they are. And still, you can do all the same things you can do with a list. But as we talked about, the element-wise calculations are really nice. Well, this is actually done in a list, right? So it's not gonna. So this is actually a concatenation in Python because these are Python lists. So this is what that's trying to show, that it'll just put them together. The behavior is different with a series. Like if we had, what we're doing here is creating two series based off of these lists, right? And if we add them together, they'll actually do an element-wise summation. But you could still do the concatenation, this behavior here. You just have to do a pd.concat on the two series, and it'll give you the kind of the same structure that you've got with lists. So that's a quick intro to series. Now let's move on to data frame, the star of the pandas library. So here we can initialize a data frame multiple ways. Here's one way to do it. We're using a dictionary, actually, if you look carefully. This is a dictionary with two keys, product and price. One of the, again, anything can go in the values, as long as it's list-like for a data frame. So we're putting in these three items. These are strings. And then the prices are going to be whatever S1, whatever series 1 was, which I believe was just 100, 200, 300, yeah. Okay, so let's look at it. So now we've created a df variable, and it's got our data frame of two columns, product and price. And these are 3 rows. Here's how we can add a new column to that data frame. So now we're after the fact, we can append columns. This one is units sold. So now we can do computation between columns. Right, so we're multiplying the price times the units sold to give us revenue. To save a new column called revenue. There you go. And we can also bring in data from an Excel sheet. And so we're reading in Excel. You may need to install a specific package to support this. Or it might work right away. I can't remember. And so here we're bringing in this data that we had in this that I keep in the folder for treasury yield curve rates. So if we look at what this is saying, read in I believe whatever is in that first sheet, since it's defaulted. So here's what here's what Treasury XLS is equal to. So it's got dates, tenors, terms, and then the yield curve rates for October 2019. And here's one, and then we're plotting. Here's a plot using Excel, and then we also have more of a normal yield curve for 2018 of May. And so let's see how we can do that in Excel, or sorry, in Pandas. So we have this data frame we brought in, and so we can take a look at the columns. We can describe the data frame. Describe is kind of like summarizing the data within this data frame. It'll just give you a quick overview of like the counts in each column, like how much, the mean standard deviation, minimum, and then the max, and these 25% of the data, is this. We can transpose columns to rows. So now, right now we have um, the um, the terms as columns, right? But we can flip that around and show, okay, now these are, now the dates become the columns, and the rows are the are um, are the terms. So how do we do that plotting? We use another library called matplotlib, and you can do what we've done is we've done this plot based on it's a lot easier to do when you've transposed the data, um, and we just all we did is the dot plot uh, function, and so it's taking each one of these. I had to do the transpose on in Excel as well when I created that chart. And so it's just going to take, let's see, each row and plot. We're using each column it's its own line to plot through each of the rates. So we can also read in the next sheet for that for last year's curve rates. And let's see. What's interesting though is the sheet, this data doesn't have the 2-month term for rates. So we can do an interpolation between this column and the third column, and there's different ways to approach this. We'll just do a simple linear interpolation, and so if we run it, we'll see that it's just grabbing the midpoint between these two values. And so there are other ways to fill in missing data depending on maybe depending on what your source is, and there's a great tutorial from Pandas that gives you different options depending on the data type, depending on the situation. So let's do the plot again and see that this is a more normal yield curve as opposed to October 2019. Okay, so now that we have that, we can source data not only from Excel, but we can also source data from a CSV file. And so, using the read CSV method. We've already talked about Excel, so I don't need to go through that. But it does require an additional package to be installed. And so we can also commonly, we're going to need to read data stored in a database. For that, I find the best is SQL Alchemy, this package called SQL Alchemy, because it supports a lot of different databases, as long as you have the correct connection string. You might, need to install a package here. It'll tell you if it's like a special database that it can't connect to, but we're going to connect to a SQLite database instead. I've just stored some data file here in this DB file. So we'll connect to it, and then with pandas you can run SQL directly on against the connection of a database. Now it's outside of the scope of this course to teach SQL, but you can look up a guide. So here we're selecting all the data from this table called Walmart stores. So let's see what that looks like. So here are all the Walmart stores. Guess the size of them. Here's the columns. But this is how to ingest data into a data frame from a database. So we've done from data, from Excel, from CSV, and now we need to do finally from the web. So from the web, we're gonna need pandas. So this is a different library that you will need to install as well. And it's a really nice library that you can review. It's got a bunch of different database APIs, so you can get remote access from different sources. The EconDB, Quandl. So the one we're looking at right now is Quandl, but any of them can work. So you do need an API key though. So you do need to sign up and get an API key. Right now, I store that in a environment variable, and so you can run through with your own once you set it up to get a Quandl API key.